Hey fellow coders, before we dive into the fascinating world of JavaScript closures, here's a quick one for you. Why do JavaScript developers prefers dark mode? Because the light attract bugs, but closures keep them contained. Now let's unravel the mystery behind closures in JavaScript. JavaScript closures are functions that can access values outside their own curly braces. In order to call a function in your code, the JavaScript interpreter needs to know about the function itself and any other data from the surrounding environment that it depends on. Everything needs to be neatly closed up into a box before it can be fed into the machine. Take, for example, a pure function that only depends on its own arguments and internal data. What we have here is a fully self-contained closed expression. When it's called, it gets pushed into the call stack where it's executed and its internal data is only kept in memory until it's popped back off the call stack. But what if that function references data outside of its own scope, like the global environment or an outer function? That leaves us with an open expression that references to other free variables throughout the environment. Now, in order for the interpreter to call this function and also know the value of these free variables, it creates a closure to store them in place in memory where they can be accessed later. That area of memory is called heap, and unlike the call stack, which is short-lived, heap can keep data in memory indefinitely, then decide when it needs to get rid of it later with a garbage collector. So a closure is not just a function, it's a function combined with its outer state or lexical environment. We can create a closure by defining an outer function that contains the state and then an inner function that operates on it. The data contained here will not leak out to the surrounding environment. The inner function has access to data defined in the outer function scope, but the outer function does not have access to the inner function. In addition, many JavaScript APIs are callback based, and you can use closures to create a function factory that takes an argument and then returns a brand new function, which can then be passed along to other functions that can expect a callback. Let's take a look at one of the most famous JavaScript trick questions, which is frequently asked in interviews. What does this code log out? But first, let's go through it line by line. Firstly, we are declaring a variable I with the var keyword. Then a for loop that will run 3 times by incrementing that variable. Now, inside the for loop is where closures come into play. We define a function that console logs the variable I. This is not a pure function because it depends on a variable outside of its scope, therefore creating a closure. Then from there we set up a timeout that pass the log function as callback. This queues up a task to execute the log function after 100 milliseconds. So what do you think the output of this code will be? We are capturing the I variable in the closure for each iteration of the loop. So it would seem that it should log out 0, 1, 2. But if we log it out, it actually console logs 3 times. To understand why that happens, we also need to understand the difference between var and let. When you use var in a for loop, that variable actually gets hoisted up to the parent scope, which in this case is the global scope. Watch what happens when we change the variable to let. We get our original expectation of a console log of 0, 1, 2. With var, we have a global variable that we are mutating over and over again. But with let, we are creating a variable that is scoped to the for loop. In other words, it's local to the for loop and can't be accessed outside of it. Now remember, a closure is the combination of a function and its lexical environment. In the case of let, the closure is capturing the log function along with the variable I for each iteration of the loop. So it would be 0, 1, 2. If we didn't have a closure here, JavaScript would allocate that I variable in memory in the call stack and then immediately release it. But because we do have a closure, it stores the variable in heap memory. So it can be referenced again when that closure is called by the timeout in the future. But when var is used, it's capturing the reference to the global variable. The reason it logs 3 times is because the timeout doesn't run until 100 milliseconds later, which is long after that for loop has been completed and iterated up to 3. We can actually examine this behavior in the browser DevTools by adding a debugger to the closure. If you try to run this code in the browser with the DevTools open, it will take you to the sources tab and allow you to inspect the call stack and scope of the function. When let is used, you can see that we have a block scoped variable named I. But when var is used, that variable is now in the global scope, which changes the way it's captured by the closure. Now that we are done with the explanation of closure, let's also check few different solutions to get 0, 1, 2 from the previous question. In the first solution, which we already discussed, we have used let instead of var to achieve this. Using let creates a block scoped variable. So each iteration of the loop gets its own variable I, and the closure inside setTimeout captures the correct value. The second solution is to pass the value of I as a parameter to setTimeout. By passing I as a parameter to the log function inside setTimeout, you are creating a separate copy of I for each invocation of log, preventing the closure issue. The third solution uses an ify immediately invoked function expression. An ify creates a new scope for each iteration of the loop, allowing you to capture the correct value of I inside the closure. And the fourth solution is to use bind to set the context and pass parameters. The bind method allows you to set the this context, null in this case, and also pass parameters to the function. This way you can ensure that the correct value of I is passed to the log function. Each of the solution addresses the closure issue and ensures that the correct value of I is logged in the setTimeout callback, that is 0, 1, 2. And there you have it, the fascinating world of JavaScript closures. Thanks for joining me on this journey. If you have enjoyed this exploration, don't forget to hit the like button, subscribe for more content, and as always, happy coding.